All right, as you can see here, today's topic, temperature conversion. By the way, coming to you live from Gerbe basement. So I'm feeling very Wayne and Garth at the moment. I feel like I should have like some kind of intro, like, you know, Gerbe's world, it's Gerbe's world. But anyway, whatever. So temperature conversion, very, very easy topic, but there are a couple of equations that I have to teach to you. So here we go. Keep it simple. So the first one is K equals 273.15 plus degrees Celsius. Now something I want to make sure we make note of here is the fact that here Kelvin is purposely not measured in degrees. There's no such thing. Also, okay, with Celsius, it is measured in degrees. So Kelvin or Celsius and Fahrenheit are measured in degrees, whereas Kelvin is not. So that's the first equation we need to familiarize ourselves with. Now, the algebra, the opposite of this would be that degrees Celsius is equal to K minus 273.15, right? Note, again, the degrees Celsius. Now, there's a couple of other equations because we want to be able to convert between Celsius and Fahrenheit themselves. So the next one is degrees Celsius is equal to, what this is equal to is 5/9 times, and this is really important, you got to put a parentheses here, and that is degrees Fahrenheit minus 32. Likewise, the opposite, the algebra on that would be degrees Fahrenheit equals 9/5 degrees C plus 32. Now, for some odd reason, and I'm a math teacher, but this is not essential to have in parentheses. And in fact, I think if you were going to put anything in parentheses, you end up having to put this part in parentheses here. Now, PEMDAS, right, would take care of that for us anyway because we would do the multiplication here before we do the addition. So, those are your four equations that you would use for temperature conversion. And in a minute, I'm going to do a couple of examples involving them. Alright, now, as promised, let's do a couple of examples of temperature conversion problems. So I'm just going to be making them up off the top of my head. Got my calculator here in case I need it. You always want to have one around. So let's start with, 398 Kelvin to degrees Celsius. So I want to know degrees Celsius, I know Kelvin, so I'm going to pick this equation right here. So degrees Celsius is equal to K minus 273.15, right? So now it just becomes plug and chug. So 398 Kelvin ends up being inserted right here. So this is equal to 398 minus 273.15. You do the math on this and you get 124.85. Now, we were looking for Celsius, so it does get a degree symbol and a C. Fair enough. Alright, let's see now. Let's go now from Celsius to Kelvin. So if I wanted to go from Celsius to Kelvin, let's see. 75 degrees Celsius is what in Kelvin? So I just picked a number again. So we want to know Kelvin. So this one's really easy. 273.15 plus degrees Celsius. So K equals 273.15 plus degrees Celsius. You do your math, you insert. So 75 ends up being put in right here. So you get 273.15 plus 75. Pull out my trusty calculator just to be sure that I don't make any mistakes. 273.15 plus 75, I get 348.15. That would be measured in Kelvin, therefore there is no need for a degree symbol. All right, let's come on over here. Let's do one now that's a little more complicated. But I'm going to be nice to myself. So I'm going to say to myself, okay, what if we have 32 degrees Fahrenheit? And we want to know what that is in Kelvin. Now, when you look at your Kelvin equations, right, they both involve Celsius, not Fahrenheit. So the first thing we're going to have to do is we're going to have to take this Fahrenheit and we're going to have to put it into something that we can use. Well, this equation here tells me if I know Fahrenheit and I want to know Celsius, I can plug it in here. So I'm going to do that first. So what ends up happening here is degrees Celsius is 5/9. Can't forget the F minus 32. Okay? Now when you go to do this, you end up plugging in things. So equals 5/9. The 32 ends up right here, so it's 32 minus 32. Now what do y'all know? 0, right? So 5/9 times 0 is equal to, indeed, 0. So that's 0 degrees Celsius. Now that doesn't answer my question, because I wanted to know what it was in Kelvin. So when I take a look at this, I say to myself, okay, I want to know Kelvin. Celsius is 0, 273.15 plus 0. Okay, so 273, just to be thorough, plus 0 equals 273.15. Now when we go to label this, no degree symbol, and K. Now there's one more thing I want to talk about with regards to Kelvin and why Kelvin is like this universally used temperature versus Fahrenheit or Celsius. You see, we have a problem with Fahrenheit and Celsius, and it is this. Fahrenheit and Celsius allow us to have both positive and negative numbers. So you can have negative 11 degrees Fahrenheit, right, or positive 11 degrees Fahrenheit. Well, where that's a problem for us is when we do things involving proportions. Because this positive and this negative would not be accounted for as being, 22 degrees different, right? It'd be 11 degrees to get to 0, and then 11 more to get here. So there's 22 degrees, right? So the delta would be 22 degrees Fahrenheit between these two numbers. So how do we account for that? We use Kelvin. And so one of the things that's actually very interesting is 0K, which is equal to negative 273.15 degrees Celsius, is actually given a name, and it's called absolute zero. Now, we have not, as scientists, actually been able to get completely down to it. We've gotten pretty darn close. But the fact of the matter is it's absolute zero. So, we've gotten pretty darn close to absolute zero. And what this means is that, even with solids, right, with all types of matter, those particles are in motion. Well, the hypothesis is that at absolute zero, that motion completely ceases. Okay, now if that was to occur, obviously, at absolute zero, we would have quite a disaster on our hands. All right, so that's temperature conversion. I think you have a few examples in your packet, things you're doing, but I think you should be okay from there. Signing off.